And the idea was that each person on the panel, and that's going to be Wim and Brian McPherson is our honored guest from engineering and EGI today. He's a researcher we want to exploit. Give maybe some vision about it, what we think the transition in energy will look like between now and the times when we are on a path, a truly renewable path of truly renewable energy. And I distributed those sheets of paper with questions just to stimulate your thinking. If you please mark on those papers those questions which you find the most interesting for us to discuss, or if you have your own questions, write them down and then hand them down over to us, that we can kind of in a collective discussion discuss some of those questions. So it's going to be, I don't want it just to be a panel discussion. I want it really drawing on the thinking and the wisdom of many activists here in the auditorium as well. Yes.
I guess while we're getting settled, I'll introduce myself. My name is Brian McPherson. I'm a professor in civil and environmental engineering, as Professor Ehrbar mentioned, and my focus of research is carbon capture and storage. So it's 5 years ago it was a niche area of research. Now it's not so niche, and but it does have some implications. Well, plenty of implications for the discussions over the past day and over the coming day. My training is in geophysics and groundwater hydrology and surface water hydrology, so I focus on fluid dynamics and the like. Therefore, that leads to my research in carbon dioxide, which at the pressures and temperatures of the deep subsurface becomes a liquid, and closer to the surface becomes a gas, which in the context of some of the questions asked here is pretty relevant. So that's who I am.
My name is Cardoen. I'm a scientist at the Center for High Performance Computing, and my background is in theoretical physical chemistry, and I'm also working with HPMC.
HPMC?
The Healthy Plant Mobilization Committee, the organizing committee.
Okay. And as Professor Ehrbar mentioned, I think a lot of dialogue, I think all of us agree, a lot of dialogue discussion is appropriate here, because I'm going to interject a lot of opinions, my own personal opinions, along with results from research and other sources of information.
Yeah, I think that's what we need. We need really, the questions which I drew up here are questions which I've had in my mind, which I kind of discovered over time as I got more into the energy issues, that these are relevant questions. And I would like to know, I'm kind of thinking other experts in the field, or the true experts in the field. I can't really call myself an expert. I'm more like starting to get into it. Must have similar questions in their minds, and how do they think about it? What is their judgment? So it is a session about reasonable expectations and projections by the experts about what is going to happen in the short and medium term in terms of energy.
Hans, couldn't Mr. Firmage make it after all?
Ed Firmage, yeah, he is not here. I just realized it.
He just didn't come?
What?
He just didn't come, or did he have
I don't know why he didn't come, so
Maybe a bit late.
maybe he'll be late, yeah. Okay, who wants to start with their own vision? Brian, do you have a vision about how this transition is going to look like?
I don't know if it's a vision as much as it is an opinion, and it's not necessarily a popular opinion. I gave a presentation on Thursday evening for the Museum of Natural History, and in that presentation I discussed carbon capture and storage, as I mentioned, the focus area of my research. And the punchline of that presentation is that carbon capture and storage, the idea being to capture CO2 from point source emissions such as coal-fired power plants, compress that CO2, those greenhouse gases, and inject it into the deep subsurface, where it came from to start with. Because we draw oil, gas, and coal out of the subsurface. That's where the carbon comes from, combusted, emitted into the air. The idea is to put it back where it came from. And simple, straightforward concept in principle, but fairly complex in terms of the potential outcomes, because it's much easier to withdraw. Well, I wouldn't say it's much easier to withdraw, but when companies withdraw carbon, oil, gas, and coal, it's there's much less worry about what's left behind. When you put it back, there's much more worry about what happens following that putting back process. But the upshot of the presentation is that carbon capture and storage is a bridge technology. Right now, we're effectively, as a global community, not doing very much to combat greenhouse gas emissions. Mostly because of political discourse, a lot of controversy and disagreement over what is the best approach. And we're effectively shooting ourselves in the foot with all of the political discussions, again, my opinion, because every day that nothing happens is another day that more CO2 goes into the air. A lot of legislators, in particular, and it's not exclusive to the state of Utah, but in the past week I had lots of presentation material just gifted to me by the legislature, in that it highlighted the fact that there's a huge amount of controversy, political controversy. So I was in a way delighted by the controversy because it provided context for what I was going to present. But what I also emphasized is that this controversy is not limited to Utah. It's very much prevalent in the East Coast and the coal country in the Midwest. The political problems with this prevent firm decisions from being made, but the science suggests that something needs to happen pretty quickly, and you've gotten that picture over the past couple of days, I think. I think that CCS is, when I first started in CCS research 10 years ago, I thought it was a pretty silly idea, and couldn't imagine why, carbon capture and storage, CCS, couldn't imagine why anyone would want to do this. Why not just stop the emissions? That made a lot more sense at the time. But now, especially over the past 10 years, and as the political discussions have and implications have evolved and strengthened, it's become a lot more clear that you can't simply just stop the emissions. You can't just turn off coal-fired power plants. You have to have a base load. Okay, renewables are wonderful sources of energy. Geothermal, right at this stage in time, is a point source of energy. And you go to areas where you have a high temperature gradients in the subsurface from which you can extract geothermal energy. So very good base load locally. Solar power, wonderful in places like Utah and New Mexico, where we have well over 300 days of sunshine. But again, on cloudy days, it's a little bit reduced at least. And certainly at night, you don't have that constant source of power. So it's not base load. Likewise with wind power. Wonderful for places like New Mexico and southern Utah, where especially in the spring, it's really, really windy. But different seasons of the year bring different degrees of windiness. So it's not, again, it's not a constant baseload source of power. Fossil fuels are a constant source, constant baseload power. So it's, they are a means for providing these lights on a constant basis, right? And it's, that's why it's not going away. Along with the political discourse, that's one reason why it's not going away quickly. So I view carbon capture and storage as a means of continuing to use fossil fuels. That's how it's posed, but not for very long. In my opinion,